Okay, so here's our next section looking at complex fractions. So complex fraction is just an expression containing one or more fractional expressions in the numerator, denominator, or both. So I have some examples right here. So basically, it's just when you have a fraction within a fraction. Okay. Now, this example right here would be pretty easy. You would just do, keep, change, flip. So you'd have 5x squared over y, then change it to multiplication, then flip the bottom. You'd have a y squared on top over 10x, and then you would simplify accordingly. Okay. Those aren't the kind of problems we're going to be looking at here. Okay, these are going to be more complicated than that. We can't do keep, change, flip on these examples. So like looking at number 59, I can't like keep, change it to multiplication and then flip the denominator. It doesn't work that way. So we're going to have to use a different method here. Okay, and so the way this is going to work is that we're going to eliminate the fractions within the fractions. Okay, so looking back at this example up here, instead of doing keep, change, flip, which you can do, and this is the way we're going to do these other problems, is you look at the denominators of the I like to call them mini fractions. They're the little fractions within the whole fraction, right? And you figure out what the LCD is between those. And in this case, it would be y to the power of 2, okay? And so then what's going to happen here is you multiply the both fractions by y over 2 over 1. And what this basically is right here, let me erase this part so I have more room to explain this. So this confuses students, but what this is right here, all this is right here is that's the same thing as saying y squared over y squared, right? I put the ones there for a reason. You'll see why in a second, but it's the same thing as y squared over y squared, which is the same thing as a 1, right? So I'm just multiplying by 1, but what I'm doing is I'm multiplying by something to where the y's are going to reduce down to where I won't have a fraction any longer on top or on the bottom part of it. So see what happens is the y right here, it's going to reduce with this y, and that's going to leave me with 5x squared. I still have the 5x squared. Then that y squared reduces down to just a y, and then on bottom, all I'm going to be left with, that'll turn into a 1. That'll just turn into a 1 on bottom. And then the same thing's going to happen here. I'm going to be left with 10x, and then what happens here is actually the y's just cancel out, y squared over y squared, and that turns into a 1 right there. Now, whenever my denominator is a 1, I really don't have a fraction any longer, okay? I really don't have a fraction. So then what I can do is just write this as 5x squared over y over 10x. And then you could simplify further here. You would be able to simplify further. Now, for this example right here, that's not how we typically do it. We do keep, change, flip because that's a pretty simple method. But on these problems that we're about to complete, you have to do it the way I just showed you. So you look at the denominators of your little mini fractions, okay? Figure out the LCD from those two, and then introduce that to all the numerators. Introduce it to the numerators, and then what happens is those many fractions, simplify, and then from there just see if there's anything else you can do. Okay, so let's go ahead and look at this one. So if you look at 59, what we're going to do here is I'm going to turn these into all fractions. So let's see, this will be 1 over 1, x over 1, and then minus 3 over 1. So we all have denominators of 1, except I have a 3 right there. So that's going to be the LCD here. So what I'm going to do here, and like I said, this part throws students off, but we'll talk about it in just a second. So what I'm going to do is I'm going to multiply both of the top and bottom by 3 over 1. 3 over 1. That's really just a 1 right there. What I have in red right there, this is just the number 1. It's looks different because we're trying to manipulate our problem. Okay, so what I'm going to do now is that 3 is just going to get multiplied by all the numerators. That's basically what you need to remember about this, is the LCD gets multiplied to all the numerators. So I'm going to end up with 3x over 3 minus 3 over 1. So see, I multiplied the x by 3, the 1 by 3. Now I'm going to multiply the bottom x by 3, and the bottom 3 by 3 also. And then on bottom, I'll end up with 3x over 1 minus 9 over 1, okay? And then let's see, now all these fractions should simplify into just a single term without a denominator. You don't have to have a denominator. So on this first one right here, the 3's will cancel out, okay? And that will leave me with x minus, and then 3 divided by 1, that's really just 3, right? And then on bottom, let's see, that would just become 3x minus 9, okay? Now, once you get to this point, this problem actually looks pretty similar to some problems we've done previously. And so what you want to notice is it's all or nothing, right? It's either this whole thing and this whole thing can cancel out, or they can't, right? But then what you might notice is that your denominator is factorable. And so we do want to factor the denominator. And so I can factor out a 3 on bottom, and that would leave me with a x minus 3. Oh, hey, look, I've got matching factors now. Okay, this is where you want to be careful. What's going to happen here is, yes, they cancel out, but what you have to realize is they reduce down to ones, okay? So you still have a fraction, so your answer is 1 over, and then 3 times 1 is just 3. The answer is 1/3. A common mistake is students will think the answer is 3. So be careful, because the factors do cancel out, but the top reduces to a 1. And then, yes, you're left with 3 times 1 for the bottom part, okay? So you might be thinking, what the heck is going on, right? This is some interesting stuff here. And so we're going to do, I think I've got maybe 4 more of these. It's not going to be too many, okay? And this will be useful for us in college algebra a little bit. It'll come up a little bit, but when you get into your high-level math and you need to manipulate some things, that's kind of where this will be a little bit more useful. But we will see this in college algebra a little bit, okay? Okay, one other thing I'll mention is on the homework, I believe it's only the first question will ask you for the restricted values. I don't ask you for the restricted values on the other ones because it's not necessary for us at this point. It will be, though, when we get to college algebra. We will actually find the restricted values on some of these complex fractions later. But right now, like, I'm more concerned about, can we just simplify them, right? But just real quick, this first question, you will be asked what the restricted value is. And so just look at all your denominators. And so the thing is, this really is a denominator, though, right here also. And so your restricted value would be positive 3 right there. X cannot equal 3, because if you were to plug in 3, you would get, 3 over 3 minus 1, which is fine. But on bottom, you'd get 3 minus 3, which would be 0, and you'd divide by 0, and that's an issue, okay? So your very first homework problem on this for 3.2, it'll ask you for the restricted value. After that problem, it shouldn't ask you again. It's something that we'll focus on later. Right now, I'm more concerned about just simplifying the fraction. Okay, so let's go ahead and look at our next one. So on 61 here, so I'm going to, once again, turn these all into fractions. So I'm going to make the 1 a 1 over 1, and the 3 a 3 over 1, okay? And so looking at my denominators, the ones are irrelevant, really. So, but I do have x and x. So my LCD between all my little mini fractions is an x, okay? And what's basically going to happen, if you don't want to overthink this, all that's going to happen is all the numerators are going to get multiplied by x. That's all we're doing, okay? But to justify it, I like to show my work. And so what I'm doing is I'm multiplying by x over 1 to this whole thing right here, okay? And so this is just a glorified number 1 right here. If you were to simplify this, this is just the number 1. And the point I'm trying to make is that 1 times any number is still just that same exact number. Now, it might change the way it looks a little bit, but it's equivalent, okay? And so that's what I'm doing here. I'm just doing some manipulation. So all my numerators are going to get an x. So this is going to become x over 1. Then it's going to become x over x. And then on bottom, I'm going to get 3x over 1. And then I'm going to get minus x over x. So if you notice, if you compare from here to here, all that happened was all the numerators got an x. That's it. Okay? And so then from here, you should be able to simplify all these fractions, especially the ones that have a denominator of 1. They really didn't need to be a fraction in the first place. Okay? So x over 1 would just be x. And then x divided by x turns into a 1. Anything divided by itself turns into 1 except for 0, but let's not even talk about that. Let's not worry about that. Okay, so 3x over 1 is just going to be 3x, and then minus x divided by x would turn into a 1. And then this is it. Don't try to do anything else. That's your answer. If you want to be a little extra safe, you can put parentheses around each one just to remind yourself. Don't try to cancel 1s or x's or anything like that, okay? And don't worry, you won't have to do the restricted values for this particular example, okay? Because it's a little complex. And so don't worry about that right now. That's something we'll address in college algebra. Okay. Here's another one. So this time I've got many fractions everywhere, okay? So I look at all my denominators, and I want to find the LCD for this, and it's going to be x and y, x times y. So what I'm going to do is I'm going to multiply all my numerators by xy. Okay, so that's going to show up in all my numerator spots. That's what's going to happen. Okay, all my numerators are going to end up having xy. So I'm going to end up with 3xy over x plus 3xy over y all over. Then on the bottom, let's see, I'll have 3xy over x minus 3xy over y. Okay, and so then let's see, I can cancel out the x's here, cancel out the y's here. So what happens is my denominator turns into a 1, so I'm just going to be left with a 3y plus, and then the denominator turns into a 1 here. That will turn into a 3x. And then on bottom, similar thing will happen here. X's cancel out, so now I have a 3y minus, the y's cancel out, minus a 3x. Okay, do not start trying to cancel anything out. Put parentheses around it, and then think about canceling. Well, they're not identical, so I can't cancel them out. But what I do notice is they're both factorable. The top and bottom are both factorable. And so what I can factor out of each one is a 3. So I'll do that. So on top, I factor out a 3, and that will leave me with a y plus x. And then on bottom, I can factor out a 3. That will leave me with a y minus x. Okay, I can cancel out the 3's now. The 3's can cancel out. They basically turn into 1's, right? And then so my final result is just going to be y plus x over y minus x. And that is my answer for this one right here. That's it. Okay, not trying to act like it's easy. It's not. There's a lot going on here, but you know, you might have to watch some of these examples more than once, okay? But for the most part, the homework should be pretty identical to this. You might get a couple that are a little out of the box, but the approach on all these should be pretty similar. Okay, so this next part, what's going to make this a little different is that one of our denominators is got more than just x or a 2 or whatever. It's actually got x plus 3. But the way you approach this isn't really going to change. So the LCD for this one, because you got 1, 1, and then x plus 3. So it's going to be x plus 3. It's going to be your LCD. So what we're going to do here, once again, just like the other ones, what we're going to do here is all the numerators are going to get multiplied by x plus 3. And so what's going on here, basically, if I want to show my work a little bit closer, is, let's see, x plus 3 over 1, x plus 3 over 1. So that, once again, that's just a glorified 1 right there. It looks much more complicated than it is. It's just the number 1. But what that does for me is all those numerators will get multiplied by that. So I'm going to go ahead and do that real quick. So let's see. I'm going to end up with x plus 3 all over 1 minus x times x plus 3 all over x plus 3. Okay, so that was just this top part right here. All I did was multiply by x plus 3 to both of those numerators. That's it. Okay. Now I'll do the same thing on bottom. So I still have the x plus 2. Now it's going to be multiplied by x plus 3, and then it's all over just 1 right there. So now it's time to simplify all those fractions individually, and it should work out pretty nicely. So the first one just will simplify down to x times x plus 3, and we'll distribute here in a minute. And then here you can actually cancel those out, so that just reduces down to a minus x. Okay, and then on bottom, this is just going to be x plus 2 times x plus 3. Okay, and then here what we'll do is we'll go ahead and distribute that. So let's see, that's going to give us an x squared plus 3x, and then minus an x all over x plus 2, x plus 3. So definitely leave the bottom how it is. Let's see what happens to the top, because we're going to clean it up as much as we can and then factor it if we can and see if anything can cancel out from there. So let's see, I kind of want to keep as much on the screen as possible. Okay, so 3x take away 1x. So let's see, I'm going to be left with, let's see, I'm going to write it right here. So I'm going to be left with x squared plus 2x all over my x plus 2, x plus 3. And then on top, I can factor out an x. And so that'll leave us with x plus 2. Oh, okay, that'll be interesting. And then let's see, I've got x plus 2 here and x plus 3 here also. Okay, so then what we can do is, I do have a common factor. The x plus 2's can cancel out. And let's see, that will leave me with x over x plus 3. And that's your answer. Once again, you might want to keep parentheses around the bottom just so you don't mistakenly try to cancel something that you're not able to. So if we kind of go back up here to the original, so this is where we started. My denominator, I only had really 1, okay, which was x plus 3. So all the numerators got multiplied by that, okay? And so that, see, I'm preserving the expression by multiplying everything by that. And then once I did that, that allowed me to simplify each fraction, which really only one of them needed it, okay? And then once I did that, I cleaned it up. Then I was able to factor it, and then I had a factor cancel out. And there we go. Okay, looking at 67. This is our last one, okay? This one will be kind of similar to the one we just did. That's just, there's going to be more factors involved. So look at all your denominators, and so you'll notice that on my denominator on bottom, that is factorable, and it will factor into these other two factors. And your problem will be very identical to this. Whatever polynomial you'll have that's factorable, it'll factor into the factors that you see in the other part of the expression. So let's see, I have 3 over, I'm going to color code this a little bit because I'm just going to insert this here. 3 over x minus 2. I'm going to have to give myself a little bit more room, though. Let's see. And then let's see, minus 4 over x plus 2. And then all divided by 7 over, and then this is the difference of two squares. That factors into x plus 2 and x minus 2. So looking at all my denominators, my LCD, remember, don't repeat. So I have an x minus 2, I have an x plus 2, and then I have an x plus 2 again, but it's already been covered, and then I have an x minus 2, but it's already been covered. Now, you know, you're not going to see this on your homework, but let's say you had something like this. If you had x minus 2 squared, well then, yes, that would be part of your LCD. You'd have to put the square with it, okay? But we're not going to run into anything like that in this section, so you don't have to worry about that. It's possible you could, but not. I made sure not to put questions like that in the homework. Okay, so now what I'm going to do is I'm going to multiply all my numerators by the LCD. And so I gave myself extra space just so I could just insert it in there real quick. So I'm multiplying all the numerators by x minus 2, x plus 2, x minus 2, x plus 2. Same thing down here, x minus 2, x plus 2. And then what you'll see is all these fractions will reduce. So let's see, this cancels with this, and that will leave me with 3 times x plus 2, and we'll deal with that in just a second. And then let's see, minus, let's see, the x plus 2's cancel out, and that will leave me with minus 4 times x minus 2. Okay, and then in the denominator spot, what we'll do here is the x minus 2's cancel, and then also the x plus 2's cancel, and that's just going to leave you with a 7 on bottom. So the last thing we have to do is clean up the bottom and then see if anything else will reduce or cancel. I don't think they will, but we'll check it. So I'm going to scroll down a little bit, okay? So I'm going to distribute the 3 here, and I'm going to distribute the minus 4 here. So let's see, I'm going to end up with 3x plus 6 minus 4x plus, that'll turn into a plus, double negatives, plus 8, all over 7. Okay, and then let's see, the 3x minus 4x would be a negative x, okay? And then 6 plus 6 plus 8 will be plus 14. And then all over 7. Now don't try to, don't try to do anything with the 7 and the plus 14. And so if you want to put that in parentheses, just be safe, okay? All right, so that will be it for 3.2 complex fractions, okay? Pace yourself with all this stuff, don't wait too long. Work a little bit each day because it can feel overwhelming, but if you work at it, go away for a while, come back working on it a little bit more, it'll help, I promise. All right, if you need anything, reach out, send me an email. I'm more than happy to help you out.